secant and secant. So we're going to start with cosecant, and cosecant is the same thing as sine x. So we're going to reciprocate sine x, and that's how we're going to get our. So in my table right here, I'm going to sine x. And if you forgot how to get around the circle on the quadrantals, we look at the ordered pairs. And we write the y values because we write the y values in sine. So sine is y, 0, 1, 0, 0. And then we go over to our graph and we graph it. So 0, 0, pi over 2, 1, 3 pi over 2, negative 1, 2 pi, 0. When we connect it, it's a nice smooth curve, beautiful, relaxing wave at the beach. Not a zigzag. We need to make sure that if we are at a mountain, then we're at a valley. The next thing we do is go to a mountain. Then in the middle, and from here, on the other side, I was just at a mountain, so I'm going to go to a valley, middle, mountain, middle, valley. Connect with a smooth, relaxing curve. So for cosecant, I'm going to reciprocate each of the sine values. So my first sine value is 0. What happens when I do the reciprocal of 0? I get undefined. Reciprocal of 1 is 1. The reciprocal of 0 is undefined. I'm going to abbreviate with an unofficial abbreviation. I'm abbreviating with a not official abbreviation. Okay, UNDF. Then I'm going to reciprocate negative 1. It's negative 0. And we get undefined once more. Bless you. Equals 0 at x equals pi, and at x equals 2 pi. The graph is undefined. And when we have an undefined graph, it's not. What's going to happen in our undefined graphs is they're going to be asymptotes. It doesn't always make an asymptote when something's undefined, but it is going to make an asymptote for the. So it's going to be a vertical asymptote. I should be specific. Asymptote. Pi at x equals 2 pi is I'm going to put a vertical dashed line. So it's there, but it's going to help me graph cosecant. Because asymptotes pass through it. So it's going to help me graph it. Now, goes on forever and ever and repeats the same cycle. I'm looking at my asymptotes right now. I've got a few asymptotes, but there's more. It's every place that sine was originally 0, where you can see here at negative 0, it's now an undefined asymptote. So every place that sine was 0, we have an I even graph the rest of it, there's a line that says, what are the asymptotes? I've listed 3 of them. Here's 3 of them. I've listed 3 of them. It wants me to write every single asymptote. How many am I going to have to write? 7? So is the window that I'm looking at the entire graph? The window I'm looking at is not the entire graph. I can see 7 of them, but I have to write all of the asymptotes. So how many asymptotes will I write? There's more than 7, Jeffrey, because this goes on forever. I'm just not going to draw it forever. Adam? Infinitely many? Yeah, like I can't, I mean I can, but I'm not going to list them separately because that's too many of them to write. I mean, there's 3 of them that I wrote out, but what I'm going to do is I'm going to come up with a formula that takes care of all of the asymptotes. So what I need to know is I need to pick one asymptote, and we're all going to pick the same asymptote because it's going to make it so much easier if we all have the same asymptote, for you to check your answers and know that you're doing it right, and for me to check your answers, especially if we have to type stuff in Canvas. Okay? So we're all going to pick the exact same asymptote. We're going to pick the first non-negative asymptote. In my picture. I'm going to look at my picture. I'm going to pick the first non-negative asymptote. What is that? Right? X equals 0. Okay, so I'm going to have the asymptote of x equals 0. And then we need to do something to that asymptote so that we can get every single asymptote forever that there ever was. So what I'm going to ask you now is we're going to add on how far apart are asymptotes. So to get to 0, to get from 0 to the next asymptote, what do I have to add on? Pi. And to get from pi to the next asymptote, what do I have to add on? Pi. And to get from 2 pi to the next asymptote, what do I have to add on? And to get from 0 to the previous asymptote, what do I have to add on? Negative pi. So they're all values of pi that I'm adding on. To get from this 0 all the way to like this farthest asymptote, I'm adding 3 pi's on. So they're all values of pi. So we're going to add on the difference. Difference between multiplied by a variable. Okay, so we're going to add on the difference, which is pi, and I'm going to multiply that by a variable. I'm going to choose k. Okay. Will that work for every single asymptote? If I start at 0 and I add on some value of pi, will I get to any other asymptote? Will that work? Can you give me an example that does not work? Can you give me a value of k that does not work? One half. If the k is the number 1/2 and I multiply that by pi, that will not get me to the next asymptote. So I got to specify something about k. It can't just be any number. Ryan? So whole numbers are 0, 1, 2, 3, 4, 5, and so on. It has to be an integer, thank you. So it has to be an integer. So I'm going to put it up on the top here because I'm running out of space down there. So K has to be an integer. And then you have to say this. You have to specify that. You have to say it. There's a few different ways that you could say it. Okay, I'm going to put it down there, but it's going to be so messy that's why I wanted to write it above it. I'm going to come right back up and write some more notes up there. But like you'll put like a comma, and then you could, if you wanted to, write K is an integer. I'm going to show you a different way of writing it, though. You might like better. So you could write it out. If you forget what I'm about to show you, you can write out K is an integer. Or you can use symbols. So I'm going to write the symbols, then I'll write the definition of this symbol so you know what it means. Okay. This thing in the middle is kind of messy. I got to fix it, so don't copy it down yet. There. It's kind of like a curvy E thing. All right. And that stands for K is an element, which is the E, is an element of the set of integers. So that is saying that K is an integer. Okay, but it's like a lot quicker to write it. I don't know if you noticed, mathematicians have to do a lot of writing, so they come up with a lot of shortcuts, a lot of shorthand. I'm sure you remember from geometry, all those different symbols. Or did you forget all of geometry? You burned it from your memory. Okay. So for this particular one, I'll put it in a different color. What color can you guys see? Blue? Does blue stand out? So for this particular one, I would probably write it as x equals k pi, comma, k is an element of the integers. That's how I would write this one on my answer key. Why did I not write the 0? Ryan. Right, I just simplified it. 0 plus something, I don't need the 0. Okay? All right, we're almost done. Didn't actually finish the graph yet. So now at pi over 2, we have a value of 1. And at 3 pi over 2, we have a value of negative 1. Now that's not enough to see the graphs. Remember the first day we did this, we found all those little decimals and it took forever. I could do that. How about I just do one of them? And then you guys can trust me on what these graphs look like. If I did pi over 6, it would normally, for sine, would be a half. If I did pi over 6, cosecant would be 2. So it'd be like here. And then there would be another one over here. This graph is going, oops, that was messy. This graph is going to look like this. So these are not parabolas, but they definitely have that same kind of shape. They're not parabolas. Parabolas get further and further and further and further out forever. These get closer and closer and closer to that asymptote, but they do not pass through the asymptotes. And then we follow the pattern. So the one that is higher will open up, and the one that is lower will open down. The one that is higher opens up, and the one that is lower opens down. And that's what cosecant looks like. So the yellow part that I made for sine, you do not need to graph that. I wanted you to graph it so you can see how the two pieces for sine broke apart and flipped. That's what I was doing with my hands. The two pieces of sine broke apart and they flipped. All right. And that's the parent function. So from there, we'll have transformations. Let's look at cosine. All the same work, a little bit faster now because I don't have to explain asymptotes. Same thing. We're going to have the cosine graph. The original cosine graph are the x values around that circle. 1, 0, negative 1, 0, 1. So I'm going to go ahead and graph those. And then I will continue my pattern. So we have a mountain, middle, valley, middle, mountain, middle, valley. And then I will reciprocate each of the cosine values. So 1, undefined, negative 1, undefined, 1. Every place that there is an undefined becomes an asymptote. X equals pi over 2, x equals 3 pi over 2. So every place that cosine touched the x-axis at 0, that is now an asymptote. You guys can compare the asymptotes for secant and cosecant. Are they in the same place? They're not in the same place. But other than them being shifted, everything else is kind of basically the same. Our points 0, 1, pi negative 1, and 2 pi 1. Anytime it is on the top, it's going to open up. If it's on the bottom, it's going to open down. If it's on the top, it's going to open up. If it's on the bottom, it's going to open down. And just like the sine and the cosine graphs look a lot alike, the secant and the cosecant graphs look a lot alike, but they're not exactly the same because they're not in the same place. For the asymptotes, we need to pick the lowest positive or the smallest non-negative asymptote. So the smallest non-negative asymptote. Luke, where is that? Pi over 2. And then when we have to add on how far apart all the asymptotes are multiplied by k. So Liam, how far apart are these asymptotes? So I'm going to say k pi. But that's not enough. I do also need to say that k is an element of the integers. So k is an element of the integers. K is an integer. And then we're done. And then we add on transformations. Did I go too fast, or are we ready to move on? I'm not sure what that noise meant. Sure. You want me to do a countdown? Just kidding. So anytime the point is the higher point, it's going to open up. If it's the lower point, it's going to open down. And after these two, I'm not going to draw that sine or cosine graph in there. So you'll see it without that little squiggly in the middle. Okay? So for this next one, the first thing that I do is decide if this is a sine or cosine graph flipped. Cosecant, which one is that? That's sine. So I personally get things messed up in my head, especially if something distracts me. So I like to write down sine, and then I also like to write down the sine values. So the sine values around the circle are the y's, 0, 1, 0, -1, 0. So I just write those down before I flip them. So now I'll go ahead and flip those, and I will have undefined. I will have 1, undefined, -1, undefined. So those are my key points, and now we're going to transform them. Use transformations. Dylan, what does the 3 in front do? Vertical what? Stretch. So I'm going to multiply all of my vertical numbers by 3. And now we have a problem because we have an undefined. It's not a problem. So I just happen to have an undefined line in my hand right now. Rubber band. Okay. Something I could stretch. So I'm going to go ahead and put that vertical line in there. And I'm going to vertically stretch it. You ready? I'm not going to make it snap. I can't stand that. How is this vertical line, by the way, that goes on forever, changing when I stretch it? Okay, but lines don't have width. They only have length. Okay, but it already goes to infinity. Changing. Which, Jeffrey, isn't that what you said at first? Yeah. Yes. But you can see, like, so lines go on forever already. So if I stretch it, like, nothing's changing. So nothing changes about the undefineds when I do a vertical stretch. So they're still undefined. But these numbers change. Kevin, what does the +2 do? Add 2 to the y. So we're going to add 2 to the y. That's going to be a translate up 2. All right, and now I have the undefined. So if I take my rubber band, which is a vertical line that goes up 4, and I'm going to make it go up 2. It already goes on forever. So if I make it go up 2, what's happening? Nothing different. Like it doesn't matter. It's a vertical line that goes on forever. As long as I keep it moving vertically, it's still vertical. What can possibly make this move? What's going to change this? A stretch doesn't change it. A translate up or down doesn't change it. What can change it, Ryan? Yeah, if I do this, that's going to change it. But we don't have one for this. So I still have undefined. And 5, undefined. -1, undefined. So every place that I have an undefined, which is x = 0, x = pi, and x equals 2 pi, those are going to be my asymptotes. And then I will follow that pattern because they're all the same distance apart. Then I'm going to plot pi over 2, 5. I'm going to plot 3 pi over 2, negative 1. And then I'm going to continue that pattern. We have to have 1 up, 1 down, 1 up, 1 down. If it is up, it will open up. If it is down, it will open down. And then we have to write our asymptotes. So I'm going to start with x equals. We always want to start with the smallest one that is not negative. Robbie, what is our smallest asymptote that is not negative? 0. So I'm not going to write it because it's 0. And then, Evan, what do I need to add on? Because they're each pi apart, we'll have k pi. And then we need to say that k is an element of the integers. Right, next. Yes, no, yes, there you go. This one starts with secant. Secant is cosine. So I'm going to write down my cosine values first because I personally make mistakes if I don't write them down. 1, 0, negative 1, 0, 1. Then I will flip each of those numbers. 1, undefined. Negative 1, undefined. 1. Okay, then we're going to look at transformations. Blake, can you pick a transformation to tell me about? It doesn't have to be all of them, just pick one. Okay, so you're talking about inside of the parenthesis. Remember that the minus sign is actually plus sign when it comes out. So we're going to go to the right pi. So that goes on the x side. Now to add pi, you might need like 2 pi over 2 plus pi over 2 and get 3 pi over 2. But sake of time, I'm doing it quickly in my head. But when you do it yourself, you might have to find common denominators and add them. So I'm adding pi, I get 2 pi. I'm adding pi, I get 5 pi over 2. And then I get 3 pi.
Wait, but don't you put it in C group?
Sure. I don't really care about these.
I made that mistake for some
Okay. So if there's nothing multiplying, then I usually just put it next to it. If you want to move it all the way to the C, that's totally fine.
I made that mistake multiple times.
Did you multiply and add in the wrong order? Or did you just...
I multiplied and added. I got the x coordinates. I just put them in the wrong
column?
Yeah.
That's okay. That's okay. As long as you get the correct x coordinates. I tend to ignore the letters. I just like to work my way out and just remember order of operations. the tables that I printed out don't have A, B, C's, and D's on them. They also don't have the X's written in them, because this would be something you guys should know. It's from 0 to 2 pi. Okay. All right. The other transformation, Nico. So he's talking about the negative sign. We've got to reflect in the x-axis, but also attached to that, Sebastian, what's also attached to that negative sign? And what's that do? In a vertical stretch, right? So we can multiply -2 at the same time because they're both multiplication. Remember, for undefined, nothing's going to change. And I'm going to go over and I'm going to draw my asymptotes. I've got an asymptote at 3 pi over 2. I've got an asymptote at 5 pi over 2. And then I will continue that pattern the same distance apart. And since I'm talking about asymptotes, I'm going to write them down too. Cameron, as you're graphing your asymptotes, can you tell me the smallest non-negative asymptote? Pi over 2. Is that what you said? Yeah. Okay. I was hoping that's what you said. It's hard for me to hear in the masks. Pi over 2. Yeah. So that wasn't actually in our table, but that one is the smallest one that's not negative. Then we're going to add on. And Todd, how far apart are they? What should I add on? Pi. So what will I actually add on?
Pi over 2.
K pi. And then we write K is an element of the integers. So it is important that we say that. All right, and we'll go ahead and graph pi -2, 2 pi 2, 3 pi -2. Continue our pattern. If it's up, it opens up. If it's down, it opens down. Let me move on. Yes? I would highly recommend that you graph the asymptote, because then you know not to go further than those asymptotes. If somebody were to not graph them, I can draw what I have seen in the past. Like if somebody were to do this, then I would mark it wrong. Okay, I would just highly recommend that you just draw the asymptotes so that you don't make mistakes like that, and then it's easy to also write them down because you can see the first one. They're not really there though, so. All right, this last one has a trick. It doesn't have a trick. It has something that you all forget. So it's going to seem like a trick. Now let's start with our secant is which one? Secant is what? Cosine. And cosine is going to be 1, 0, -1, 0, 1. I will flip those. 1. Undefined. -1. Undefined. 1. Transformations. Peter, pick a transformation. Tell me about it. Oh my gosh, Peter, you rock. Does anybody know where he got that from? Because I don't see a 2 pi in the question. Factor. Good. You have to factor it. If you have a horizontal stretch or shrink and a horizontal translation, we have to separate them. They cannot be in the same room. So we will factor it out. Secant 1/2 x plus, and when you divide by 1/2, it's the same thing as multiplying by the reciprocal, 2. We get 2 pi right here. So we will left 2 pi, subtract 2 pi. And Chris, can you tell me the other transformation that's happening? Oh my gosh, don't write down what I wrote down. Don't even write down what I wrote down. You already did. What did I screw up on? Adam. Yeah. I can't subtract first, and I just got so excited that Peter, who, you know, we didn't work this out ahead of time, I just randomly called on him and he gave me the right answer. I got so excited that I went ahead and just went with it, and I was wrong. So I will come back to that. Chris, what's the other? Multiply which? The x's by 2. That's a horizontal. Is that a stretch or a shrink? It's going to get bigger if we multiply by 2, so it's a stretch. That's what I should have done first. Okay, 0, pi, 2 pi, 3 pi, 4 pi. Now I will subtract 2 pi. And I have nothing going on the y, so I'm ready to find asymptotes and graph them. Looks like I have an asymptote at x equals negative pi. Oops. So if you're sitting here going, I don't know how she's getting those asymptote values, you should ask. Don't wait. Put your hand up. Stop me. I have another asymptote at x equals pi. That was just an example. Maybe it's something else that you're not understanding. You should ask right away. All of my asymptotes are going to be the same distance apart. So if these asymptotes are 4 blocks apart, then the next asymptote is going to be 4 blocks away. I've got negative 2 pi 1, 0, negative 1, and 2 pi 1. If it's on top, it opens up. If it's on the bottom, it opens down. And when I say top and bottom, I don't mean positive or negative. I just mean where it is according to the other. I mean, it's going to be. We're going to answer all this information. So typically, period is going to be the same period as it was for cosine. So what's a cosine period before transformations? Parent function. Two pi. Thank you, everybody. And anytime we change the period, it would be if we do a horizontal stretch or shrink, which we did. Multiply that by 2. Yes?
Your values that are like above the x line,
My bad. That happened, did it? Is that weird that they all moved? How are they connected? Okay. But I don't know. I don't know. Okay, every single time I have a question, I can be like, why is this happening? And they could just answer me. I have no idea who I would even ask that to. Horizontal translation. So did we move left or right? We moved to the left 2 pi. Our vertical shift, did we move up or down? Nope. Answer the question. Domain in asymptote. I'm going to fill out the asymptote first. I think it's easier. Which is the first Tom. What's the first? At pi. Right, so we're going to start with pi. And then tongue. Now I'm going to write it. So they're 2 pi apart. And then we say of the integers. Okay, now I'm going to back up to the way the right. What values are being graphed? All of, but not the asymptote. Piece of the graph. With the U shape. Tell me I don't have to do that. How many pieces of this graph are there? Infinitely many. So I am not going to write this in interval notation. I can't do it. Don't make me. Okay? We're going to write it in set notation instead. We're going to say that basically x is all the real numbers except x is not the asymptotes. So to say that, I'm just going to say that x is not pi plus 2k pi, where k is an element of the integers. So the difference between my asymptotes and my domain here is the asymptotes are those, the domain are not those. Yeah, I don't know what happened, why it closed, sorry. The domain would be everything except the asymptotes. So the asymptotes are not included in the domain, but everything else. It's exactly the same thing as the asymptotes, only it says does not equal to. How about the range? How far down to how far up? Does it go all the way to negative infinity? Yes. But it doesn't go all the way up. It does go to positive infinity, but it doesn't go interval all the way up. It's missing some numbers in there. So when you think about interval notation, we need a separate set of parentheses or brackets for every piece. There is a bottom piece and there is a top piece. So I'm going to have two pieces together with a U. So we start with the bottom piece. It goes all the way down to negative infinity. It goes all the way up to what number? -1. So our range for this is going to be negative infinity, comma, -1, bracket, because it does equal -1, union, and then we do our top piece. The very bottom of our top piece is 1, and from there it goes up to positive infinity. So we do bracket 1, comma, positive infinity.